Good evening once again. Let us begin our today's video. I think we were doing something on forces. Just a moment, let me load my PPT. Okay, fine. Hello, my name is Ratan Rao. I teach physics in an international school in Bangalore, and teaching is my passion. And apart from it, I do also some regular videos on misconceptions in physics. Okay, so to begin with, we have already changed it. Okay, I think we will be beginning with thermal physics. I have some questions on thermal physics from today onwards. We'll be doing on thermal physics. So today's topic is understanding potential energy. And if you want to view all my videos, you can view it in my website, which is ratankar.com. I think today's video would be around 106th video, okay, in that video series. Okay, let us maybe continue. Right, let me take my pen. Right. So a solid piece of tungsten melts into a liquid without a change in temperature. Which of the following is correct for molecules in the liquid phase compared with the molecules in the solid phase? So this is what we have got. The student responds, so there are four options here. So what is he asking is that tungsten, you have a set of tungsten, this is tungsten, which melts into a liquid, which means what? You are going to heat it. You are going to heat it. And as a result of it, there is no change in temperature. When you heat a substance, definitely there should be a change in temperature. But here there is no change in temperature. The reason is because it's in a transition state. Okay, solid gets converted to liquid. So now this is in a solid state. Now this is getting converted to a liquid state. Which of the following is correct for the molecules in the liquid phase compared with the molecules in the solid phase? Which of them is correct? So towards it, kinetic energy and potential energy is said. So most of the students, they gave an answer like this. They said that, okay, since the temperature is not changing over here, it says without a change in temperature, we know that kinetic energy is only because the average kinetic energy is named is only because there's a change in temperature. Okay, so this is what we know in thermal physics. So since there's no change in temperature, this delta T becomes zero. And as a result of it, the average kinetic energy, change in average kinetic energy is also equal to zero. Our final kinetic energy is equal to initial kinetic energy, which means when the substance is in the form of a solid, it had some kinetic energy, some 10 joules, for example. The same kinetic energy is also observed when it is in a liquid state. Okay, so this is what people thought. And then they said, okay, kinetic energy should be same. Okay, so kinetic energy is same. Now, therefore, options C and D are incorrect. It should be between A and B. And then, since the object is not being lifted from one end to the other end, maybe in the gravity, we are not going to lift it up. No such thing has been given over here. So they thought maybe the potential energy does not change. And as a result of it, the option B is the right answer. Now, this is a misconception. Why is it a misconception? The reason is because, see, when I talk about potential energy, the first thing that comes to our mind is nothing but potential energy is equal to mgh, which is not always true. Okay, potential energy by definition is nothing but the change in the energy of the particle due to its position with respect to, if it is gravitation, then it is with respect to Earth. If it is not gravitation, and we are discussing something about two molecules and one molecule is moved apart, then what could be the answer? Will there be a change in potential energy? Now, what happens is in ice or maybe in a solid state, what happens? You see the molecules are closely situated like this. They're very closer to each other. When you heat, the molecules will now get separated, which means what? One molecule, this is the first molecule, second molecule is here, third molecule is here. Now you see, the positions of these molecules have changed. When the positions have changed, then what would you expect? Doesn't the potential energy also change? Right? Potential energy should change. The reason is because potential energy is associated with the position of a molecule. So in case of the solid state or ice, you observe that the molecules are closer to each other. When you increase the temperature and as a result of it, there's a change in the state of the material. It means solid gets converted to liquid, then automatically the molecules move farther apart. When they move farther apart, which means that one molecule, if I take one of them as reference, the other molecule is moving farther apart. The potential energy will change. I didn't say anything about increase or decrease. Okay. So I said that it changes, right? So therefore, it would be changing. And now we know that potential energy is given by mgh. But if it is gravitation, what do? We write potential energy is equal to some minus g mm divided by r, if you remember this. So usually what happens is potential energy is proportional to 1 by r. Okay. So as a result of it, potential energy, when the value of r is decreasing, this becomes negative. Why this becomes lesser negative? Lesser negative. It's already negative. It becomes lesser negative. What do you mean by negative potential energy? That means they are being bound together. They cannot escape. Now, when the energy becomes lesser and less negative, what do you mean by that? That means that the energy becomes less negative, which means what? The particle can escape, right? So, in other words, the potential energy has now increased, right? So, I'm saying, for example, initially in a solid state, the potential energy is some minus 5 joules. Now, upon heating in liquid state, this could have been minus 1 joule. Now, which one is greater? This is greater as compared to this, right? So, as a result of it, the right option is A and not B. I hope you understood this problem. So, if you really like this problem, do share, comment, and subscribe to my channel for more updates. So, this would really help me in doing more number of videos. Thank you, friends, for watching this video. Thank you.